In a previous video note, we looked at the fields and constructors of the clockDisplay class. We noted that a clockDisplay object creates and makes use of two numberDisplay objects to keep track of the hours and minutes of the current time. Each numberDisplay object acts as a counter, going through the values 0 to 23 or 0 to 59, depending on whether it's recording the hours or the minutes. In this video note, we're going to look at the process of creating the two numberDisplay objects when the constructor of clockDisplay is called. To visualize this process, we're going to make use of the debugger, which is an integral part of the BlueJ IDE. A debugger is a useful tool, not just for finding programming errors, but for investigating the way that execution flows between different methods and the collaborating objects that make up a program. We want to find out what happens right from the point of starting to create a clockDisplay object. Since this is the role of the constructor, we're going to ask the program to pause as soon as the clockDisplay constructor is called. clockDisplay has two constructors, so we're just going to use the one that doesn't take parameters. We instruct the program to pause by placing a breakpoint at the first statement of the constructor. Left-click in the margin immediately to the left of the code area. A red stop sign appears. Breakpoints can be removed by clicking on them. We'll put this one back. Now, as soon as we create a clockDisplay object in a normal way, the editor window is displayed with the breakpoint line highlighted, and the debugger window is also shown. The debugger window has an area to show instance variables. We can see the three fields of clockDisplay and that they are currently set to null. This reflects the fact that object variables do not automatically contain objects. Object variables that are fields are always initialized to the value null by default. This value means no object. In other words, if we tried to use those variables as if they were already referring to objects, we would get an error. So the main role of the clockDisplay constructor is to arrange for those fields to be initialized with objects. That involves creating two numberDisplay objects for the hours and minutes fields, and creating a string object for the current time for the displayString field. First of all, we're just going to step through the statements of the constructor one by one to show that this is exactly what happens. Then we will repeat the process but drill down a little further into the steps involved. At the bottom of the debugger window are buttons marked Step, Step Into, Continue, and Terminate. If we select Continue, the constructor call literally continues without further breaks until it is completed. And if we look at the object bench, we have a normal clockDisplay object. Since that's not terribly instructive, let's remove that object and create a new one. The breakpoint is still there. This time we select Step in the debugger. The result is that the second line of the constructor is now highlighted, and an arrow shows where we've moved on to. What has happened is that the first statement of the constructor has been executed, and a new numberDisplay object has been created and assigned to the hours field. We can see this in the instance variables area, because now the hours field no longer shows null but object reference. In other words, the hours field has been initialized fully to refer to a numberDisplay object. However, the other two fields remain as null, so step once again, and we see that minutes has now been fully initialized. The next statement in the constructor is a call to update display. This is a method that is defined in the clockDisplay class. If we were to scroll down the editor, we would see it. But even better, let's use Step Into to actually move the point of execution into the update display method, so that we can follow the flow of control more closely. What we see here is a string concatenation operation that involves asking the hours numberDisplay object to return a string for its value, and the minutes numberDisplay object to do the same, and then joining those two strings together, separated by a colon character. We won't step into this time, but just step. Notice that the result of the concatenation is assigned to the displayString field, so by the end of the update display method, which is where we are now, the displayString field is no longer null, but set to the starting time of the clock. One more step, and we've returned back to the point immediately following the call to update display from the constructor. A further step, and construction of the clock display object is complete, and it's on the object bench. Let's repeat the process using the second constructor this time, adding a breakpoint there. We can either leave the existing breakpoint where it is or remove it. We can have as many breakpoints as we wish in the code. When creating this clock display, we choose the constructor that allows us to set the current time. Once again, the breakpoint stops us just before the two number display objects are created. We use step for the first two statements, and then step into the setTime method. SetTime consists of three statements. Update display is called last, and we've already seen how that works. But the first two statements illustrate how the two number display objects receive the initial values corresponding to the current time. So let's step into the first of those calls. This is the one to the setTime method of the hours number display object. Notice that the call sequence area of the debugger window is showing three entries. The method we are currently in is at the top, and something called init is at the bottom. This is an internal name for the constructor. What this area shows is that we are currently 3 levels deep in constructor and method calls. We started by calling the constructor of clock display. The constructor then called the clock display setTime method, which in turn called the setValue method of one of the number display objects. All of those calls are still active, and that's what is shown here. If we step through the actions of the setValue method, we can see that it's a standard setMutator method that makes sure the parameter's value is within this particular number display's range of valid values. If it is, then assignment to the value field is permitted. If not, then no assignment is made. Watch what happens in the call sequence area when we step on at the end of the setValue method. The call is cleared at the top of the sequence, and the new top value is setTime, which is where we currently are. A further couple of steps results in the display time field being set to the current time value we provided to the constructor. In summary, in this video note we've illustrated the process that clock display objects go through to initialize their fields. In particular, we've looked at a class that has fields of object types, number display and string. We saw that fields of object types have the value null until they've been assigned an object. One of the main roles of the constructor of a class with object fields is to ensure that those fields are properly set up to refer to appropriate objects. We use the debugger to show how flow of control can be visualized, which is a useful feature additional to its normal role of helping us to find bugs.